XQ-58A Valkyrie, History, Present, Future and Impact. Introduction. The XQ-58A Valkyrie, developed by Kratos Defense Security Solutions, is an unmanned combat aerial vehicle UCAV designed to enhance the capabilities of the U.S. Air Force and other branches of the military. As part of the low-cost Attritable strike demonstrator LCASD program, it represents a significant innovation in military drone technology. This report delves into the Valkyrie's history, its current operational status, future developments, and the broader implications for military strategy. History and development. The XQ-58A Valkyrie was conceived as a response to the changing landscape of aerial warfare, where the need for cost-effective and attritable systems has become paramount. The first flight occurred on March 5, 2019 at Yuma Proving Ground, Arizona. The Valkyrie was initially designated the XQ-222 and was developed under the USAF Research Laboratory's low-cost attritable aircraft technology LCAT project. Design features. The Valkyrie features a stealthy design characterized by a trapezoidal fuselage and advanced aerodynamics, including stealth technology, designed to minimize radar cross-section. Multi-launch configurations, capable of being deployed via rocket boosters, trolley launch, or conventional takeoff and landing CTOL. Cost-effectiveness. With a unit cost projected at $2 million, it allows for large-scale deployment without the financial burden associated with traditional aircraft. The Valkyrie is intended to serve as a loyal wingman, supporting manned aircraft such as the F-22 and F-35 in various roles, including reconnaissance, electronic warfare, and kinetic strikes. Operational history. The operational milestones of the XQ-58A include 2019, first flight. 2021, successful sixth test flight, demonstrating the opening of its internal weapons bay and the launch of a small drone. 2022, the U.S. Marine Corps ordered 2 units for testing under the Marine Corps Penetrating Affordable Autonomous Collaborative Killer PAACK-P program. 2023, conducted extensive testing, including flying in formation with an F-15E, which showcased its capabilities in advanced combat scenarios. The Valkyrie has also been integrated into the Skyborg program, which aims to deploy unmanned systems as expendable wingmen for manned aircraft. This integration marks a shift toward an operational model that emphasizes collaboration between human pilots and autonomous systems. Present status. As of 2025, the XQ-58A is actively undergoing testing with both the U.S. Air Force and Marine Corps. The Marine Corps has particularly focused on developing the MQ-58B variant, which is optimized for electronic warfare and suppression of enemy air defenses. The ongoing tests are part of a broader effort to assess the Valkyrie's effectiveness in real-world scenarios, with a focus on its potential to mitigate risks to manned aircraft. Variants and future capabilities. Kratos Defense has announced several variants of the Valkyrie, with at least 5 in development. These include XQ-58A, the original prototype; MQ-58B, designed for electronic warfare. Additional variants, focused on enhancing capabilities in areas such as payload capacity and operational flexibility. The introduction of a CTOL variant, which includes built-in landing gear, expands the Valkyrie's operational capabilities, allowing it to operate from traditional runways and enhancing sortie rates. Future developments. The strategic landscape is evolving, with a shift towards addressing near-peer threats posed by nations like Russia and China. In this context, the Valkyrie is expected to play a critical role in future air combat strategies. The emphasis on attritable and cost-effective platforms aligns with military objectives to enhance operational capacity while minimizing risk to personnel and expensive aircraft. Key future developments include increased production, plans to scale production to potentially 250 to 500 units per year depending on demand and operational needs. Enhanced autonomy, continued advancements in the Valkyrie's autonomous capabilities, allowing for more complex missions without direct human control. Integration with other systems, ongoing efforts to ensure seamless integration with existing manned aircraft and future autonomous systems. Impact on military strategy. The XQ-58A Valkyrie represents a paradigm shift in military aviation. Moving away from a reliance on a few high-cost aircraft towards a larger fleet of affordable drones. This shift not only enhances operational capacity but also addresses the high attrition rates faced by modern air operations. Ethical considerations. The introduction of autonomous systems like the Valkyrie raises ethical questions about decision-making in combat scenarios. Concerns about accountability, the potential for unintended consequences, and the moral implications of autonomous weapons continue to be debated among military leaders, policymakers, and ethicists. Conclusion. The XQ-58A Valkyrie is poised to significantly reshape aerial combat, providing the U.S. military with a versatile and cost-effective solution to modern warfare challenges. As the military continues to explore the integration of autonomous systems, the Valkyrie's development will likely influence future air combat strategies and operational concepts. Balancing technological innovation with ethical considerations will be essential as the military navigates this new frontier in warfare. XQ-58A Valkyrie, History, Present, Future, and Impact. History and Development. The XQ-58A Valkyrie is an unmanned combat aerial vehicle UCAV that represents a significant advancement in military drone technology. Developed by Kratos Defense Security Solutions, it was initiated under the U.S. Air Force's low-cost Attritable strike Demonstrator LCASD program. Its first flight took place on March 5, 2019 at Yuma Proving Ground, Arizona. The Valkyrie was conceived as a solution to the growing need for cost-effective attritable systems capable of operating alongside high-end manned fighter aircraft such as the F-22 and F-35. The design of the Valkyrie emphasizes stealth, featuring a trapezoidal fuselage and advanced technologies that enable it to perform various combat roles, including reconnaissance, electronic warfare, and kinetic strikes. The projected unit cost of approximately $2 million enhances its appeal as a loyal wingman to manned aircraft, allowing military strategists to deploy it in more aggressive and riskier scenarios without the same level of concern for pilot safety typically associated with human-operated aircraft. Operational history. The operational journey of the XQ-58A has been marked by a series of significant milestones. First flight, March 5, 2019. Sixth test flight, March 2021, demonstrating internal weapons bay functionality. Marine Corps order, December 2022 for extensive testing starting in October 2023. Formation flights, August 2023, flying in formation with an F-15E showcasing its integration capabilities with manned aircraft. The Valkyrie has also been involved in advanced testing under the Skyborg program, which seeks to explore the use of unmanned systems as expendable companions to manned aircraft. Current status and future developments. As of now, the Valkyrie is undergoing further development and testing, with at least 5 variants in the pipeline, including an MQ-58B model focused on electronic warfare capabilities. This aligns with the military's ongoing shift towards addressing threats from near-peer adversaries such as Russia and China. The potential for the Valkyrie to be enhanced with features such as built-in landing gear for conventional takeoff and landing CTOL capabilities speaks to its versatility. This configuration allows for greater operational flexibility, potentially increasing sortie rates and payload capacity, which are critical in contemporary combat scenarios. Impact on military aviation. The introduction of the XQ-58A represents a paradigm shift in military aviation, moving away from a focus on a limited number of high-cost aircraft to a larger fleet of more affordable, attritable drones. This shift is designed to enhance operational capacity and reduce the high attrition rates faced by modern air operations. The ethical implications of deploying autonomous systems in combat scenarios are still a matter of debate. However, the Valkyrie is set to influence future air combat strategies significantly. One of the more counterintuitive aspects of the Valkyrie's development is the notion that lower-cost expendable drones can actually enhance the survivability of high-value manned aircraft. Traditionally, military strategy has emphasized the protection of pilots and expensive assets. However, the Valkyrie's deployment allows for a more aggressive posture where drones can be sent into high-risk situations to absorb enemy fire or conduct reconnaissance missions that would otherwise endanger human pilots. Ethical considerations. The ethical implications of deploying autonomous drones like the XQ-58A cannot be understated. Concerns about decision-making in combat. Accountability in the use of lethal force and the potential for dehumanization of warfare are prevalent. Critics argue that reliance on autonomous systems could lead to reckless behavior by pilots who may feel less connected to the risks faced in combat, potentially leading to a greater willingness to deploy drones into dangerous situations. Moreover, the discussions surrounding the Valkyrie's autonomy raise questions about the role of artificial intelligence in warfare. While proponents argue that AI can enhance operational efficiency and safety, detractors warn of the unpredictable consequences of allowing machines to make life-and-death decisions. Conclusion. In summary, the XQ-58A Valkyrie is poised to reshape the landscape of aerial combat significantly. By providing a versatile, cost-effective solution to modern warfare challenges, it enhances the capabilities of human pilots while also sparking vital discussions about the ethical implications of autonomous combat systems. As military strategies evolve in response to the changing nature of global threats, the Valkyrie's role as a loyal wingman exemplifies a transformative approach to airpower that balances cost-effectiveness and ethical considerations. Important content in the XQ-58A Valkyrie report that may be overlooked. The XQ-58A Valkyrie, while celebrated for its technological advancements and cost-effectiveness, also embodies deeper implications for military strategy, ethical considerations, and the future of warfare that are frequently overshadowed by its technical specifications and operational capabilities. Below are several critical aspects of the Valkyrie program that deserve closer attention. 1. Transition from high-cost to low-cost warfare. The Valkyrie represents a shift in military strategy from a reliance on fewer high-cost aircraft to a larger fleet of low-cost, attritable drones. The unit cost of approximately $2 million is a crucial detail that underscores this transformation. This affordability allows for greater risk acceptance in combat scenarios, enabling the U.S. Air Force to deploy more assets without the fear of significant financial loss. The strategic implication here is profound. Modern warfare may increasingly rely on quantity over quality, particularly against near-peer adversaries with advanced air defenses. Significance. This change could lead to a fundamental rethinking of military resource allocation and deployment strategies, emphasizing mass drone operations capable of overwhelming adversaries. 2. Integration with manned aircraft. The integration capabilities of the Valkyrie with manned aircraft such as the F-22 and F-35 are noteworthy but often under-discussed. The Valkyrie acts as a loyal wingman, enhancing the capabilities of human pilots while mitigating their risk. This operational model can shift the dynamics of air combat, allowing for coordinated attacks, reconnaissance, and electronic warfare without exposing pilots to direct threats. Significance. The potential for enhanced situational awareness and operational flexibility through integrated drone and manned aircraft missions could reshape tactical air combat, making it more efficient and lethal. 3. Ethical implications of autonomous warfare. The Valkyrie operates under the premise of increased autonomy, sparking ethical debates regarding the use of AI in combat. Critics express concern about delegating life-and-death decisions to machines, fearing a lack of accountability and potential for misuse. While proponents argue that human oversight remains a critical component, the extent of autonomy in decision-making is a pivotal topic that is often glossed over in favor of technical achievements. Significance. The ethical ramifications of deploying autonomous weapons systems like the Valkyrie could influence public perception of military engagements and international laws surrounding warfare. necessitating a broader discourse on accountability and morality in combat. 4. Emergence of new warfare tactics. With the introduction of loyal wingman drones like the Valkyrie, new tactics are likely to emerge, necessitating a re-evaluation of military training and engagement strategies. The concept of swarming, where multiple drones operate collaboratively to engage targets, could redefine mission planning and execution. Significance. The shift in tactics could lead to a transformation in combat operations, requiring military leaders to adapt to a landscape where drones play a central role alongside traditional forces. 5. Supply chain and production capabilities. The potential to produce between 250 to 500 Valkyries annually is an aspect that may not receive much attention but is crucial for strategic planning. The ability to manufacture drones at scale ensures that the U.S. military can maintain operational readiness and replace losses rapidly. Addressing the high attrition rates associated with modern air operations. Significance. A robust production capacity can provide the U.S. military with a strategic advantage, especially in prolonged conflicts where attrition is expected to be high. This could alter the balance of power in conflicts against adversaries with less flexible supply chains. 6. Variance and adaptability. The development of multiple variants of the XQ-58A, such as the MQ-58B, focused on electronic warfare, highlights the adaptability of the Valkyrie to meet evolving military needs. This versatility allows the U.S. military to tailor drone capabilities to specific mission requirements, enhancing its operational scope across various domains. Significance. The ability to adapt drone capabilities rapidly can ensure that the military remains responsive to emerging threats and technological advancements, potentially providing a competitive edge in future confrontations. 7. Role in contested environments. The Valkyrie's design and capabilities are particularly relevant in contested environments, such as potential conflicts in the Pacific against China. Its ability to operate from non-traditional launch platforms like shipping containers or mobile launchers increases its operational flexibility and reduces dependency on fixed airbases, which could be prime targets in a conflict. Significance. This capability can enhance survivability and operational effectiveness in scenarios where traditional airbases are compromised, ensuring that U.S. forces can project power in contested regions. 8. Potential for foreign sales and global influence. While the Valkyrie is primarily focused on U.S. military needs, its design and production capabilities may attract interest from allied nations. The potential for foreign sales of variants could not only provide financial benefits to Kratos Defense but also influence global military dynamics by enhancing the capabilities of allied nations. Significance. Strengthening allied military capabilities through shared technology can create a more unified front against common adversaries. Reshaping geopolitical landscapes and deterrence strategies. Conclusion. The XQ-58A Valkyrie represents a significant advancement in unmanned combat technology, but its implications extend far beyond its technical specifications. By recognizing the strategic, ethical, and operational nuances associated with the Valkyrie, military leaders, policymakers, and the public can better understand its potential impact on future warfare. This awareness is crucial for navigating the complexities of modern military engagements and ensuring that advancements in technology align with ethical considerations and strategic objectives. For valuable points for in-depth analysis and discussion of the XQ-58A Valkyrie. 1. Cost-effectiveness and operational flexibility. The XQ-58A Valkyrie represents a significant shift in military aerial strategy, primarily due to its cost-effectiveness. With a unit cost projected at around $2 million, it provides a stark contrast to traditional manned fighters that can cost upwards of $85 million, such as the F-35. This affordability allows the U.S. Air Force and Marine Corps to adopt a fleet-style approach, deploying multiple drones to absorb potential losses in high-risk environments. The ability to operate alongside advanced manned aircraft as a loyal wingman enhances mission capabilities while mitigating risks to pilots. Furthermore, the Valkyrie's adaptive design, which allows for various launch methods including rocket-boosted trolley launch and conventional takeoff and landing, provides operational flexibility that is crucial in modern warfare scenarios where airbases may be threatened. 2. Integration with manned aircraft and tactical evolution. The Valkyrie's design and operational capabilities enable seamless integration with existing manned aircraft such as the F-22 and F-35. This integration is vital for enhancing situational awareness and expanding the tactical envelope of air operations. The drones can perform a variety of roles from reconnaissance to electronic warfare, thereby multiplying the operational effectiveness of human pilots. The introduction of the Skyboard program aimed at developing autonomous wingmen highlights the evolving nature of air combat strategies. This shift not only transforms how missions are planned and executed but also necessitates a re-evaluation of existing doctrines regarding manned versus unmanned combat roles. 3. Ethical and moral considerations of autonomous systems. The deployment of the XQ-58A raises significant ethical questions regarding the use of autonomous systems in warfare. As the Valkyrie is designed to operate with a degree of autonomy, concerns arise about decision-making in combat scenarios, especially concerning lethal force. Critics argue that delegating combat decisions to AI-driven systems could lead to moral and accountability issues, particularly in scenarios where civilian lives may be at risk. The historical context of unmanned systems and their impact on warfare ethics highlights the need for transparent guidelines and regulations governing autonomous combat systems. The ongoing debates regarding the balance between technological advancement and ethical responsibility will be pivotal in shaping future military policies. 4. Future developments and strategic implications. The Valkyrie's continued development, including the introduction of variants such as the MQ-58B, highlights the U.S. military's adaptation to emerging threats, particularly from near-peer adversaries like Russia and China. The expansion of the Valkyrie's capabilities, such as enhanced electronic warfare features, reflects a strategic pivot towards countering sophisticated air defense systems like the S-400. This evolution in drone technology not only influences air combat tactics but also signals a broader trend in military modernization, emphasizing the need for agility and adaptability in response to rapidly changing geopolitical landscapes. The potential for the Valkyrie to operate in collaboration with naval forces further underscores the importance of joint operational capabilities in multi-domain warfare scenarios. Conclusion. The XQ-58A Valkyrie stands at the forefront of a transformative era in military aviation, characterized by cost-effective unmanned systems that enhance operational flexibility and tactical capabilities. However, its deployment also prompts crucial discussions around ethical considerations and the future trajectory of warfare. As military strategies evolve, the implications of integrating autonomous systems like the Valkyrie will be felt across various domains, shaping the future of combat and national security. Famous historical cases of military aviation technology. 1. The development of the F-117 Nighthawk stealth technology. The F-117 Nighthawk, developed by Lockheed Martin, was the first operational aircraft designed around stealth technology. Its development began in the late 1970s, and it made its first flight in 1981. The Nighthawk played a crucial role in the Gulf War, using its stealth capabilities to evade radar and conduct precision strikes with minimal risk to pilots and aircraft. The F-117's introduction marked a significant shift in aerial combat, emphasizing the importance of stealth in modern warfare. The aircraft's success laid the groundwork for future stealth designs, including the F-22 and F-35, similarly to how the XQ-58A Valkyrie aims to enhance the capabilities of existing manned platforms. 2. The introduction of the MQ-1 Predator drone. The MQ-1 Predator, developed by General Atomics, was one of the first drones to be used extensively in combat, beginning operations in the mid-1990s. The Predator was primarily used for reconnaissance and surveillance, but later evolved to carry out armed strikes against enemy targets. Its use marked a turning point in military strategy, allowing for remote engagement in conflicts without risking pilots. The Predator's impact on military operations is similar to the anticipated role of the XQ-58A Valkyrie as a loyal wingman, augmenting the capabilities of manned aircraft while minimizing risks. 3. The evolution of the B-52 Stratofortress. The B-52 Stratofortress, introduced in the 1950s, is a long-range subsonic jet-powered strategic bomber that has seen continuous service in various conflicts including the Vietnam War and the Gulf War. Its design allowed for adaptability and upgrades over decades, ensuring relevance in changing warfare environments. The B-52's ability to carry a diverse payload and perform various missions from conventional bombing to nuclear deterrence mirrors the versatility that the XQ-58A Valkyrie aims to achieve with its multiple configurations and roles in modern combat scenarios. The longevity and adaptability of the B-52 serve as a model for how the Valkyrie could evolve in the future military landscape. Future outlook for the XQ-58A Valkyrie, predictions and implications. The XQ-58A Valkyrie is on the verge of becoming a transformative force in modern aerial warfare, driven by advancements in technology and the evolving nature of global military conflicts. As we look ahead, several key predictions can be made about the Valkyrie's future, its operational role, and its broader implications for military strategy and ethics. 1. Expanded operational capabilities. As the U.S. Air Force and Marine Corps continue to refine the Valkyrie's design and functionality, it is expected that at least 5 variants will be fully operational by 2025. This includes the MQ-58B, which focuses on electronic warfare capabilities, a critical need given the rising sophistication of enemy air defenses. The integration of multiple payloads such as kinetic weapons and electronic warfare systems will allow the Valkyrie to perform diverse roles from reconnaissance to direct attack, thus enhancing its value as a multi-mission platform. 2. Increased fleet size and production. With a unit cost around $2 million, the Valkyrie offers a financially viable alternative to traditional manned aircraft, which can exceed $80 million each. As military budgets evolve, there is a high likelihood that the production rate of the Valkyrie will increase significantly. Kratos has already indicated the potential for producing 250 to 500 units per year. A larger fleet of Valkyries would enable the U.S. military to adopt a strategy of attrition, where they can afford to lose several units in combat without crippling financial repercussions. 3. Integration with manned aircraft. The Valkyrie's role as a loyal wingman will likely expand with increased operational tests in conjunction with advanced fighters like the F-35 and F-22. This collaboration will foster the development of new tactics and operational frameworks that leverage the strengths of both manned and unmanned systems. In contested environments, Valkyries can absorb enemy fire, conduct reconnaissance, and deliver payloads, thereby safeguarding human pilots while maximizing combat effectiveness. 4. Ethical and strategic considerations. The integration of autonomous systems into combat raises significant ethical questions regarding decision-making in warfare. The Valkyrie, while designed to operate under human oversight, will still rely on advanced algorithms for many autonomous functions. The U.S. military will need to establish clear guidelines for the use of force by unmanned systems, addressing concerns about accountability and the potential for dehumanization of combat. The debate over the morality of autonomous weapons will gain traction as more countries develop similar capabilities, leading to international discussions around norms and regulations. 5. Global military landscape and competition. As the Valkyrie becomes operational, it will influence the global military landscape, particularly concerning near-peer adversaries like Russia and China. Countries observing the U.S. military's advancements in drone technology may accelerate their own development of similar systems, leading to a potential arms race in unmanned aerial vehicles. The proliferation of such technology could destabilize existing power dynamics, necessitating strategic adjustments from the U.S. and its allies. 6. Adaptation to future warfare. The future battlefield is likely to be characterized by increased complexity with hybrid warfare strategies combining conventional cyber and psychological operations. The Valkyrie's adaptability will be crucial in this environment, allowing it to operate not just in air combat but also in electronic warfare and cyber reconnaissance. The incorporation of AI and machine learning into the Valkyrie systems will enable it to evolve in response to emerging threats, ensuring its relevance in future conflicts. 7. Enhancements in communication and control systems. As the Valkyrie is integrated into broader military networks, advancements in communication technologies will enhance its operational effectiveness. The ability to seamlessly share data between Valkyries and manned aircraft will be pivotal for mission success, allowing for real-time tactical decisions based on comprehensive battlefield assessments. This interconnectedness will require robust cybersecurity measures to protect against potential adversarial disruptions. Conclusion: the XQ-58A Valkyrie is poised to significantly impact the future of aerial combat, symbolizing a shift towards a more integrated and cost-effective approach to military operations. Its development will prompt a re-evaluation of air combat strategies and raise important ethical considerations regarding the use of autonomous systems in warfare. As we move forward, the Valkyrie's evolution will not only reshape the capabilities of the U.S. military but also influence global military dynamics in the 21st century.